Hey, all right, so this is number 1 on the digital assignment for February 12th. This problem is asking you to solve the system of equations, y equals 2x plus 11 and y equals negative 3x plus 1 by using the substitution method. So if y equals both of these expressions, right, y equals this thing and y equals that thing, the transitive property says that these two things have to be equal to each other, right? The substitution property says that I can take this whole side of one equation and I can just substitute it in place of y in my other equation here. So I'm going to set this up when I'm solving this one using my substitution method. I'm going to take, instead of a y equals, I'm going to start it out with 2x plus 11 equals negative 3x plus 1, right? We just took the y out of this part and we plugged in the 2x plus 11. So now we're just solving it for x. And so this is a lot like what we were doing in Unit 2 when we were just solving our equations. Remember, when you have a variable on both sides of your equal sign, we want to add or subtract one of them to get rid of it. But we also know that if we do it on one side of our equation, we're going to have to do the exact same thing over here on the other side. So if I do a plus 3x here, then I have to do a plus 3x over here, right? Now, of course, these are going to cancel, and all that's left on this side is a 1. Over here on this side, 2x plus 3x is 5x, and then we still have the plus 11. Okay. All right, so now it's a two-step problem, right? I'm trying to solve and get x by itself, so I'm going to subtract 11. 5x, those are going to cancel, equals 1 minus 11 is negative 10. If I want x by itself, I'll divide by 5. Okay, those will cancel. X equals negative 2. But that's not your actual solution yet, right? Remember, just like when we were solving our systems of equations by graphing in class earlier this week, we had to find the x value and the y value because we're looking for the point where if we were to graph these two equations, the point where they cross each other. Right now, we know that point has an x value of negative 2. So if we want to figure out what the y value is that goes with it, I'm going to take my x value of negative 2 and I'm going to substitute that back in to one of my original equations. It does not matter which equation I take that negative 2 and plug it back into. I'm just going to plug it back in for x on that first equation because the first equation didn't have any negatives to deal with, but I would get the exact same answer if I plugged it in here on the second equation. So since I'm using the first equation, y equals 2x plus 11, we now know that x is negative 2, right? So I'm going to replace x with negative 2. Well, 2 times negative 2 is negative 4. Negative 4 plus 11 gives me positive 7. So my solution, the point where these two lines crossed each other, is the point negative 2, positive 7, right? And this is how you're going to give your answer. It's always going to be in the form of coordinates, just like when we were doing it on a graph. Okay. All right, hopefully this helped you with number 1. Go ahead and give number 2 a try because it's going to work the exact same way.